Okay, hello everybody. We have another lesson today. Today in section 11.5, I'm going to show you guys how to calculate the volume of square pyramids and cones. Okay, so volume of a pyramid, we use a lot of the same parts of the formula we did when it was a prism. The main difference is we only are finding the volume of 1/3 of that prism, basically. That's basically why this formula works. It's basically the volume of what would be the equivalent of this prism is the volume of the pyramid is 1/3 of that. Like if we made this into a full prism, we would need another 2/3 to fill in the whole thing. Okay, so that's not a big deal as to why the formula works there. Today we're just going to use it. Two things you need for a square pyramid is you just need to know the length of the side of the base, and then you do need to know the actual height of the prism. Notice we're not using the slant height anymore. We needed that for surface area, but for volume we need the actual height, which is, the distance from the very center of the base up to the very top point of the pyramid, which you will be given all of that. Okay, so to get the volume of this, we can see the length of our side is 6 and our height is 9. So to get the volume, we're simply going to take 1/3 times 6 squared times 9. Okay, so evaluate that out. I'm first going to take 6 squared, which I know is 36, and then I'm going to take 36 times 9, and that gives me 324 thirds, because I haven't multiplied by 1/3 yet, which is the same thing, by the way, as dividing by 3. If I take 324 and divide by 3, it does divide out evenly, so I get 108. And again, volume, so make sure you give it in cubic units, so in this case it's in cubic inches. Okay? If it doesn't divide out evenly, I'm fine if you guys want to keep it as a fraction. I think on the homework they might accept that also. Again, if they prefer that you have a decimal, just, very carefully make sure you round it where they ask you to round it if it doesn't, if the fraction doesn't divide out evenly. Okay, pause the video here, please, and try number 2. All right, so let's see how we did. So again, same formula. We take 1/2 times the length of a side squared, so the length of the side is 5. So times 5 squared, and then times the height of the pyramid, which is 7. Oop, I'm sorry, not 1/2, 1/3. My goodness, I apologize. 1/3 times 5 squared times 7. So 5 squared is 25. 25 times 7 is 175. So we have 175 thirds. And then if you take 175 and divide by 3, so this one actually does not divide evenly. So again, for me, if you want to keep it in terms of an improper fraction, that is fine. I would accept this 175 thirds cubic kilometers. If you prefer the decimal, it would be about 58.33 cubic kilometers. Right? It's one of those decimals where the number keeps repeating. It's 58.3, so rounded to the nearest hundredth would be 0.33, if you prefer that. Again, when you guys are doing the homework, as usual, just look carefully at the directions for how they want the answer to make sure you are, in fact, rounding it to the correct place. Okay, so those are the only type of pyramids that we're going to see, are just the square pyramids when it comes to volume. And then we're just going to look at volume of a cone, which is, again, a pyramid where the base is a circle. So it's essentially the same formula, except, how do we get the area of that base? Well, we simply have to take pi times the radius squared. So pi times the radius squared times the height. And again, like everything else that involves pi, you can keep your answers in terms of pi if you wish. Okay. So in this case, we're going to take 1/3 times pi. We can see we have a radius of 3. So times 3 squared, again, times the actual height of the cone, which you will be given. Again, not the slant height, but the actual height, which we are given, is 12. All right, so 3 squared is 9. 9 times 12 is 108. So we have volume equals 108 pi over 3. And then you can see if 108 divides by 3, I believe it does. 108 dividing by 3, yes, I believe it does, 36. So that divides all the way, so we can simplify it to 36 pi, and that would be 36 pi cubic feet. And that is a perfectly acceptable answer in terms of pi For those of you that prefer to give the rounded decimal answer, it would be 113.10 if we rounded it cubic feet. It's 113.0973, so we would have to round the 0.09 up to 0.10. Okay, but again, either one of these answers I will accept. All right, pause the video to try number 4, please. Okay, so try to find the volume. Once again, we're not given the radius, we're given the diameter. You got to take half of it to get the radius, so our radius is 4, right? So always watch for that. Sometimes they might give you the diameter instead of the radius. And then when we go to the main formula, again, it's going to be 1/3 times pi times our radius squared times the actual height, 12. Actual height of the cone, which is 12. All right, 4 squared is 16. Take 16 times 12, and we get 192. So I have 192 pi over 3. Okay, and then I want to see, can I take 192 and divide that by 3? And I can. 192 divided by 3 is 64 pi. Now, just so you guys know, sometimes they don't always divide evenly by 3. Like, say this did not reduce. We couldn't take 192 and divide by 3. If you left your answer like this, I would accept it like this in terms of pi. This is a perfectly reasonable answer. But if it does divide evenly, go ahead and divide it out as I did here. So 64 pi cubic yards would be the acceptable answer in terms of pi. And then as usual, if you prefer to have the answer as a decimal, on the calculator, just take 64 pi and round where they ask you to round. In this case, it would be 0.06 cubic yards. 201.06 cubic yards for that one. Okay, so this is what you'll be expected to do on this assignment. So you may go ahead and begin the homework for this, and then pretty soon we will now begin reviewing and getting ready actually for a Chapter 11 exam on everything that we've done so far with surface area and volume of these different polyhedrons. And I'll talk more about that when we do the review. And I will see you guys all at that time. Thank you very much.